Okay, so for fractions and rational expressions, where we were last class was doing common denominators, and I was just starting to add variables in. So let's just do an easy one with just numbers to start. Okay, so what's the common denominator? 12. You multiply, it's 3 times 4, so we take our first one and times it by 4 over 4, and our second one times by 3 over 3, so then they're both 12 on the bottom. Multiply the top is 8 over 12, minus 1 times 3 is 3 over 12, and then we subtract 8. 8 minus 3 is 5 over 12. And then you look at your final answer and say, can this be simplified? No. No, because I can't write 12 as 5 times something, so it can't be simplified. So that would be the end. Okay, this one. What is the common denominator? 3x, because it's 3 times x. Just like the last one was 3 times 4, this one is 3 times x is the common denominator. So this first fraction does not need to be redone. It already has a 3x. But the second one, we're going to multiply by 3. One times 3 is 3, and 3 times x is 3x. Subtract the top, so 2 minus 3 over 3x is negative 1 over 3x. Okay, number 3. Okay, what's the common denominator?
X.
It's not x. It's not x plus 1. But I'm hoping someone would say that. Because it's not right. I'm going back up to the top one. Okay, what was the 2 bottoms to start on this first one?
3 and 4.
3 and 4. So 3 plus 1 is 4. Do you agree with that?
Mm-hmm.
What was the common denominator? What did we do? Multiply them and got 12? You didn't add 1 to this one. You didn't say the common denominator is 4 and add 1, because that's not how you do a common denominator. But when there's this situation, a lot of people will do that. They'll say, oh, this is like 3 and 4, but x and x plus 1, for some reason, people want to add 1 to this. Okay, do you see in relation to the first one that that's not actually the right technique? These are 2 different numbers. They're 1 apart. It's like 3 and 4. What's the common denominator? Not quite. Yeah, you corrected yourself. But it's x times x plus 1. It's those things times. Just like in the first one, it was 3 times 4. So we take our first fraction, and we multiply by x plus 1. If anything has a plus in it, make sure you put it in a bracket. And then the second one already had an x plus 1, and we need to multiply by x. So just like in that first one, we multiplied by 3 over 3 and 4 over 4. You just multiply them together. Never add to make a common denominator. So now the denominators are actually the same. They are x times x plus 1. That's the denominator. On the top of this first one is 1 times x plus 1. And on the second one is minus 5 times x. And we add or subtract the tops once the bottom is the same. 1 times x plus 1 is just x plus 1, minus 5x. Now, how do we collect like terms on the top? We've got 1x minus 5x is how many? Minus 4x plus 1. And that's it.
So you wouldn't rewrite that as, like, for instance, the denominator in the solution, you wouldn't write that as 2x plus 1?
Okay, so you're asking, he's asking if we should multiply this out? And I would say no, why not? I mean, it's not wrong to do it, but why wouldn't we?
For factoring purposes?
Right, because anytime we have a fraction with variables in it, we're going to try to simplify, and to simplify you factor, and that's already factored. So by expanding it, what you would then have to do is factor it later. So anytime we've got a common denominator like that, it is okay to multiply it out if you want, but you are making it less simplified by multiplying it out. It's simplified when it's factored. So if you were to do that, it would look like this. X times x is x squared. X times 1 is x. So it would look like this.
Not 2x plus 1.
Right. Yeah, 2 times x is 2x. X times x is x squared. Okay, 4. Same idea. So we've got two different denominators. We are going to multiply them to find the common denominator. So our first one, because that x minus 1 is two terms, it's separated by a plus or minus sign. There's a minus sign in there. Put it in a bracket. We're going to multiply by 2x. And the second one, we're going to multiply by x minus 1. So the denominator is what? 2x times x minus 1. And again, you don't need to work it out. So that's what's on the bottom. And then you do work out the top because you have to subtract whatever's there. So here, 3 times 2x minus 5 times x minus 1. 3 times 2 is 6. 5 minus 5x. This is a minus 5 times minus 1. So minus times a minus is a plus 5. So be careful of your signs. And that might be confusing to some people. But this is what we have, is minus 5x plus 5. That minus goes into both. If you left the minus out front, you'd still have to switch both signs. So if you do it at the same time, then you don't have to do that. All right, 6x minus 5x is just x, 1x, plus 5. And that would be the answer. So, if you were to expand the bottom, 2x times x is 2x squared, and 2x times minus 1 is minus 2x. But we don't need to do that, okay? But if you were to, that's what it would look like. Okay, now this next one is the same idea, except it is going to simplify in the end. So I'm going to start to show you how to simplify these. Well, we simplified them a little earlier, but when we get to fractions and rational expressions part 2, after we do factoring, then we'll do more of this. But I'll just do one little example now. So what's the common denominator? X plus 1 in brackets times 2. And I should put a bracket around that. Anytime it has more than one term, stick it in a bracket. Okay. Okay, so the common denominator is 2 times x plus 1. On the top here, we have 2x times 2, and the other one is minus 3 times x plus 1. 2x times 2 is 4x, minus 3x, minus 3. 3 times 1. Oh, this doesn't simplify.
Wouldn't you put a bracket around the 3x minus 3?
No, we've gotten rid of the bracket. When you multiply a number into a bracket, that's getting rid of the bracket.
Okay, so that actually is viewed as negative 3?
Mhm.
Okay.
People get confused by that, but what you're doing is sort of this, adding a negative 3 times that. It's the same thing. That might help you if you stick that minus in there. You always want to put the minus into the bracket. Yeah.
Is it possible to cancel the x plus 1 on the bottom and the top?
Oh, right here?
Yeah.
No, because we just added that in, so then you're going back to where you were.
Okay.
Yeah, good question, because people do it by mistake all the time. The only time you want to cancel things, I said this last class, so we'll say it again. The only time you want to cancel things when you're adding or subtracting a fraction is in the beginning before you do a common denominator, or at the end when you have one fraction. In intermediate steps, don't say, oh, they're the same on top and bottom, and I'm going to cancel, because then you're screwing it up. Okay, it either has to be at the very end, once we have our answer, which we don't quite have here. What do we have left to do? We still have to do the top if there's anything that can join together. So there's a 4x and a 3x is just 1x minus 3 over 2 times x plus 1. Now nothing cancels here because on the top, remember this is like one term. So if there was an x minus 3 on the bottom, it could cancel, but there's not. Okay, you can only cancel things that are multiplied. And that was the rule we talked about right at the beginning. Factors are what cancels when things are multiplied. Not adding or subtracting don't cancel. The only time you can simplify a fraction is if you can write it as a multiply and then you cancel them out. For example, if we had 15 over 25, what cancels here? A 5, because we can write the factors and then cancel because they're multiplied. But you can never cancel anything if it's got a plus in it. So we can cancel, say for example, I'll go on the next sheet. If I said, simplify. Okay, here's the question. 2x over 4x minus 2. I'm telling you that it does simplify. There's no other fraction to add, so we're not doing anything. We're just simplifying. What do you think can cross out here? A 2. Right, not yet, because there is not a 2 multiplied on top and a 2 multiplied on bottom. You have to see that first before you cross them off. So what you would do is say, well, this is 2 times x, and on the bottom, we can take out a 2. So when we take out a 2 from 4x, what do we have left? 4x is 2 times x. So if we take out a 2, we're left with a 2x. Here, if we take out the whole 2, what are we left with? 1, never 0, right? Because if we take out a 2, that's a 2 times 1, so you're left with 1. Now, is there a 2 multiplied on top and on bottom? Yes, and that's when you can cancel only. So when I was doing fractions before and spending so much time simplifying, it's because this is when you mess up. Is once I put pluses and letters in there, all of a sudden you forget how to simplify a regular fraction is only when the numbers are multiplied on top and bottom. Okay? Let's look at one that's bad that I see all the time. What did you do wrong?
Cross the fours out to cancel that.
Right, why can't you cross those 4s out? X plus 4, is that X times or multiplied on top? No, this is not equal to X. What it is, equal to, is that 4 is divided by each. So this is X over 4 plus 4 over 4, which is X over 4 plus 1. You could do that. This would be okay. This is not okay. Do you see the difference? So don't get all excited when you see something that's the same on top and bottom, because if it's added or subtracted, you do not touch it. You leave it alone. Okay? Try that one. Okay, so what, do we cancel out these 5s and just have X plus 10 left? No, that would be a mistake. You can only cancel the 5 if it is multiplied by the X, but it's not multiplied by the whole top. That's the difference. It needs to be multiplied by the whole thing. So it has to be a factor of whatever's on top, which it can be by factoring out a 5. We do have an X plus 2, because 10 is 5 times 2. So if you took the 5 out, you're left with a 2. Now the 5 is multiplied by the whole top, and we can cancel it. So that would be X plus 2. Okay, so this says simplify, then add. So I'm giving you a hint, but this is what you would always do. Anytime you had to add 2 fractions, you say, can I simplify them first, so I don't get crazy big numbers. And this one wouldn't work out too bad either way. How would we simplify 1? Which one do you think simplifies? The first one, because I see a 3 and a 3, but they don't cancel. But I can factor a 3 out of the bottom. So I would write this as 3 over 3, X plus 2. You could either simplify it off to the side and then rewrite it back in, but don't not rewrite the whole question. If you're saying equals, then the whole thing has to be equal to whatever you had on top. So you'd rewrite the whole thing. So now those 3's cancel. What would we have left on the on the top when we cancel the whole top? 1. So now we actually have a common denominator. We don't need to find it. The bottom is the same. Does the 6 and the 2 cancel? No, because the 2 cannot factor out of both of those. You can't write 2 times that. There's no 2 with the X, so you can't do it. So that would be the answer. Okay, so question 1, you say, I've got to add 2 fractions. Can I simplify them before I start? Yes. Will anything factor out of both the top and bottom that will be the same?
5?
No, because the 5 can't come out of 2. 2. So this would be 2 times 5 times X on top. And the bottom we can factor out a 2. So 2 2 out of 8? 4. What about this fraction?
Divided by 3.
Yeah, a 3 can factor out of both. All right, so what cancels from the first fraction is a 2, and a 3 cancels here. So we're left with 5x over x minus 4 plus 5 over 6. So the common denominator, we can't simplify them more, so those are the denominators. So we multiply them together to get a common denominator. So our first fraction needs to multiply by 6. And our second fraction needs to multiply by x minus 4. So 5 times 6. So they have the same denominator. You can write them as one fraction and add the top. Okay. So the bottom stays, and how do we add the top? Remember, don't cancel this x minus 4. Don't get excited, because you're not ready yet until you've finished simplifying the top. This isn't the end. We have to multiply that 5 through. 5x, and 5 times 4 is 20. So 30x and 5x
35x.
minus 20. So the only way that anything can simplify now, like this is your final answer, the only way if something can simplify is if we can factor a 6 out on top, or a 3 or 2. Does anything factor on top? A 5 would. 5 goes into both 35 and 20. Do you see that? So you could do that. 5, what would we have left? 7x minus 4. They both have a minus 4. Can you cancel out minus 4s? No. Has to be the whole bracket has to match for it to cancel. So this would be as simplified as it could go. You can't do anything else. The numbers don't combine. The numbers, even though they're both minus 4, don't, because that's 7x minus 4, and that's just x minus 4. They're two different numbers, so they don't cancel. Yeah, so we're leading into some exponent stuff.
Oh, it's good.
So there's x's and y's here. We want to simplify always first, and then find the common denominator. Unless they already had the same bottom, which they don't, right? So, okay. What you've got here is, I'm going to write it out, but once we do this class on Wednesday, we won't be writing this out anymore. This is long. You're not going to do this every time, especially if I give you like an exponent of 20 or something, okay? This isn't how we're going to do it. But I want to illustrate how you do exponents, what it actually means that you're doing when you add or subtract exponents, and not just telling you that's a rule, okay? So I'm showing you why. So what did I do right now? What's it called, what I did? Not expanded. It's the opposite. I just factored. I wrote out everything in its factors. When you write them out as multiplies, it's called, even though it's bigger, it's called factoring when you write out all the factors, right? Expanding is actually when you like take this 6 and multiply it into the bracket. That's expanding. Taking the factors and writing them not as a factor anymore. But we don't, when we just have numbers like this, we don't even use the word expanding. So this is what we have. So let's cancel out what cancels. So cross them all off, anything that matches. So here we would have 1x that matches.
And 1y?
And 1y. And let's do the same thing over here. So a 2 matches, an x, 2 y's. So let's put them back as exponents, and I want you to look at what we have. So x over 3, y times y would be y squared. Nothing on the top. 1. 2, x times x is x squared, y times y is y squared. Okay, so we're not going to find the common denominator yet to add this. I want you to look at this first fraction, what we started with, and then what we have now, without doing this intermediate step. How would you get from here to here? It is, the real thing we're doing, the rule says if you've got a fraction with exponents, you subtract the exponents. So this would be 2 minus 1, because there's 1x on there. 2 minus 1 is 1, so that's 1 on the top. I don't really think of it as subtracting. Think of it this way, and you'll never make a mistake. There's 2 on the top and 1 on the bottom, so where is there more?
On top.
On top, by how many?
By 1.
1. 1's going to cancel, and there's going to be 1 left on top. Okay? Now the y's, there's 1 on top and 3 on bottom. So if that 1 cancels with one of these, how many do you have left? 2 on the bottom. Do you see it? If you get hung up in like subtracting exponents, I find people get confused and they've got negative exponents and weird things, and then they don't know what to do. Look at the top and bottom and think of it as expanded like this, it factored, and then cross off what crosses off. But you can do that in your head. You don't usually need to. If we had 17 x's on top and 20 on the bottom, what would we have left? 3 on the bottom. 17 on top, 3 on the bottom. We'd have 3 left on the bottom. So x cubed. No need to subtract and think about which is bigger, top or bottom.
So basically, when determining where the exponents goes when you simplify, majority rules.
Absolutely. Yep. So here, don't look at this intermediate step. Look what we have left. Here's the numbers, 2 and 4. So a 2 cancels. So we have 2 left on the bottom, because that's where it was bigger, right? The x's. There's 1 on top, 3 on bottom. So one of them cancels, and how many do you have left? 2 on the bottom. The y was bigger on the bottom. 2 of them cancel. 2 left on bottom. Do you see it?
Mm-hmm.
You don't need to expand, and you don't need to worry about this like rules. Should I add or subtract? Do I have negative exponents or positive exponents? Think about where there's more, and that's where they would be left over after they cancel. Okay, now let's talk about common denominator of this thing. So I want you to look at the 2. Do they have anything that they already have in common on the bottom?
Y squared.
Y squared. So we don't need to multiply either of them by y squared because they already both have a y squared. So let's rewrite the fraction just as it is, and we'll say this is, it needs to be multiplied by something, and this one needs to be multiplied by something. Not y squared because they both already have that. Do they both have a 3?
No.
No, so we need that 3 over here. They both have a y squared, so that's cool. Over here, what else? This has a 2. Is there a 2 over here?
No.
No, so we need a 2 over here. That's the 2. Y squared is already taken care of. The 3 was from that one. X squared.
And you can put over the one from the left.
We need it over here. Okay? So you need to look at the two and say, what are they missing so that they both have the same? If they both already have one part the same, you don't do it again. Then you're making things bigger, then you'll need to simplify later. So you're actually adding a step if you multiply. So what you don't want to do is what we've been doing, which is just taking this whole thing multiplied over here, and this whole thing multiplying over there. That is not the right way. Okay, you want to compare them and see what it is that they're each missing. So let's multiply this out. Still no plus or anything. What do we have on top here? We've got a 2. X times x squared. How many x's is that? It's x times x times x, x cubed. 3 x's. 3 times 2 is 6. Y squared and an x squared. Don't cancel those because that's going backwards. Remember, we're starting to do the common denominator, so you wait until the end before you start canceling anything out. The only time you cancel is before you start the common denominator or after you finish at the end. Never in between. And people get way too excited and see this and they start canceling, but then you're going back to where you started. 3 times 1 is 3. 3 times 2 is 6. X squared, y squared. Now look at them and see, oh, do I have a common denominator? Yeah, so now you write them as one fraction. 2x cubed plus 3. Anything like terms that we can add on the top? No. So we're done. Now we can say, can we simplify this? So how do you know if you can simplify? It has to be multiplied. So this is a plus sign. That's a problem. So you can't cancel the 3. You can't cancel the 2. You can't cancel the x unless you can factor it out. Looking at just the top, does anything factor out? Can you take a 2 out of both pieces? No. Can you take an x out of both pieces? No. A 3? No. There's nothing you can take out of both of these, so you're done. You can't do anything else. That would be the answer. Okay, so that's the start of exponents. So we can do exponents, and then we can make the fractions more complicated in part 2. So we'll stop there for today. Your homework is due preferably at the start of class. So when you come into class, you have it stapled already and your name is on it, and you bring it up here. And so then when I come in, there should be a big pile of them here, okay?
Just name, not student ID?
Name and student number, yeah.